Hi, everyone. I'm Jackie, and I'm going to give you a couple of questions that I think you should definitely know for this Saturday if you're taking the September 13th, 2025 SAT exam. So without further ado, let's jump in. Okay, so this one I think you should definitely know for Saturday. Um, you can solve it algebraically, or you could solve it on Desmos. Personally, I think Desmos would be a bit quicker, but I'll show both ways. First, I'm going to show you Desmos, and then we can look at it algebraically for those that want to see the algebra behind it. Okay, so let me share my screen. Ah, okay, well, here we are. Okay, so what we would want to do is type in a table. Whenever you're provided with 2 or 3 coordinates, you definitely can go to Desmos and put in a table. If you don't want to type in table, you can find that function here, table. Okay, so I'm just going to put in C8 and then 2C and 350. You see there's an exclamation point here. We need to define a slider for C. I'm just going to make it like 100. Generally, make your slider ranges between 0 to 500. Don't really exceed that. And then I'm going to type in the function. So here I'm going to make a regression with a tilde. Why am I doing that? Because we have unknown parameters and we see I have variables like C here. I want to pull information from the table. So what I'm going to do is type in Y1 and then I put in the tilde and then we're going to type in this function here. So I'm going to put a to the x, and note when you're doing regressions, you have to put x1. And also I'm grabbing the information from the x1 in the table. And then I put minus b. Oh my goodness. And there's our answer. B is 11. And you see, no matter how much I slide here, B stays at 11. Okay. Well, wasn't that so great? Now let's take a look algebraically. So algebraically, we would just type in the coordinates like we have here. So we have C8 and we would just put them into our table here. So it would be 8 is equal to a to the c minus b. Likewise, 2c 350. That would be equal to 350 is equal to a to the 2c minus b. Okay. I can see that we both have like a and c and a and 2c's to the power here. So whenever I see exponents, I think about reverse engineering them and maybe manipulating them. So I could move the b over here and do this as 8 plus b is equal to 8 to the c power. And then I could also re-express this one here using my knowledge of laws of exponents, that this is the same as a to the c multiplied by 2 minus b. Everyone sees that because if I distribute this here, I would be multiplying the exponents, which would give me this up here. Just reverse engineering and making my laws of exponents. Amazing. Oh my goodness, look, I defined what A is C is, system of equations. I can do substitution. Let's go ahead and do that. So we have 350 is equal to 8 plus b squared minus b. And then you would definitely want to expand your brackets or parentheses. And that would give me 64 plus 16b plus b squared minus b. And then here I'm getting that it's going to be a quadratic. So this would be, put everything in terms of 0. So we'd have b squared plus 15b and then move the 3. So b squared plus 15b minus 286 is equal to 0. And then usually they factor nicely. So we could either do quadratic equation or factor. This would be b minus 11 and b plus 26. And then we can see our 2 answers for is b equals 11, which is what we got when we plotted in Desmos, and then b equals negative 26. Also, you could just type this into Desmos and look at the x-intercepts, but I wanted to show how it's done without using Desmos. Okay, so know this for Saturday. Maybe you'll have something similar on the exam. Okay, next up we have this one. So here as well, we're given a table. I see that it tells me a particular function. So I can definitely go ahead and graph this. So let's do that. Just like I did in the previous question, I'm going to make my table. Do, 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 do. And then I type in the value. So be negative 27, 3, negative 9, 0, 21, 5. And then says the table shows three values of x and their corresponding values of g of x, where g of x is equal to f of x, x plus 3, and f is a linear function. What is the y-intercept of the graph? Okay, so what I can do is actually just pull what the equation will be is by doing a regression. So just like we did in the previous problem, I take y1. It's going to be taking this information from the table. Then I use tilde. And then I'm going to here note, like, I can't just type in f of x, because if I were to type in f of x, it doesn't tell me anything. Well, it doesn't tell Desmos anything what to do. It's just like f of x. What is that? We know it's a linear function, so I can feed that information to Desmos and be like, oh, Desmos, I want f of x to be a linear function. So what's the equation of a line? Mx plus b. So I would do mx1 whenever you're doing regressions, 1 plus b. I can use any variable, but right, in America, we learn it mx plus b divided by, and then I do x1 plus 3. And you can see here, b, that's the y-intercept, right? That's equal to 36. And look, that would be the answer, 0, 36. And you see, I solved that in probably under a minute if I wasn't talking and explaining things. So really quick way to help save yourself time on the exam, especially if you get something like this, I think you could get something similar. Isn't it amazing? Okay, so this one, if you were curious how to solve algebraically, or let's say Desmos wasn't working for some reason, what you do is I would just take the original equation given. So we have g of x is equal to f of x over x plus 3. I would multiply each side by x plus 3. That would cancel this here. Then it goes over here. So basically, I have that f of x is equal to g of x multiplied by x plus 3. And if I want to define what f of x is, I can use the coordinates in the provided table. So for example, we can take negative 27 and 3. And if I were to type that in, it'd be like f of negative 27 is equal to g negative 27 and then negative 27 plus 3. And then looking at the table, g of negative 27 is actually, what is that equal to? Oh, it should be 3. So this would be f of negative 27 is equal to 3 times negative 24. And basically, f of negative 27 would be equal to negative 72. So that means that the new coordinate pairs here would be negative 27 and negative 72. And then I would want to get one other pair of coordinates. Let's just do the next one. So negative 9, 0. And then same exact thing, we would do f of negative 9 is equal to g of negative 9, which would be negative 9 plus 3. And we know f of negative 9, g of negative 9, that correlates to the 0. So that's really just equal to 0 times negative 6, which is equal to negative 9, 0 again. So I know here it would be negative 9, 0. So that coordinate actually would just stay the same. Okay, so I have two coordinates. And then since I know it's a linear function, what we would want to do is use slope formula. So I could just use y2 minus y1 over x2 minus x1 equals to slope. We would do, so negative 72 minus 0 over negative 27 minus negative 9. And then that would become negative 72 over, careful here, it becomes positive. So it's negative 27 plus 9. And that would be over negative 18. And 72 divided by 18 is equal to 4. so that I know the slope of this line is y equals mx plus b, so it'll be 4x plus b. Final step to find the y-intercept. You can take any coordinate again. This one looks really easy to work with. So I just be like 0 is equal to 4 times -9 plus b, and we get that 36 equals b. So a bit more of a process, but you see, we get there to the exact same answer in the end. Okay, continuing our journey. Okay, so this one, I also believe you'll have something similar on your exam on Saturday. So let's take a look how we can really quickly solve it on Desmos. So here, just like we did in the previous problems, if you've been following along, I type in table. I'm going to type in these coordinates. We have 5.25, 1, 2.8, 16, and -2.1. Then I'm going to make my regression. And remember, when I'm making a regression, I'm pulling from the coordinates from the table. So I'm going to type in y1, and then I'm going to type in the tilde symbol, which we have here. And then I type in the function we have in the problem. So I'm going to do x or h minus 7x1. Remember, you have to put the 1 to pull from the table, and then we put it over x1 plus 14. And voila, we have the answer, h equals 49. And that is exactly what you would type into your answer sheet. Wasn't that amazing? Okay, but for those of you that would like to know how you could solve these with just algebraically without any help of Desmos, all we would do is just pick a coordinate, any one of the three in the table. I'm just gonna go with like the lowest coordinate here, so 1 and 2.8. So that would just be that that f of 1 would be equal to h minus 7 times 1 over 1 plus 14. And this would all be equal to our output, which is 2.8, and then h minus 7 over 1 plus 14, which would be 15. And then we can just multiply each side by 15. So 15 times 2.8 is 42. So 42 equals h minus 7, and 49 is equal to h. So also pretty quick and easy without without using Desmos or a calculator as well. Okay, amazing. Continuing our journey. Okay, so this one I think you also have a high probability of seeing this Saturday. If you do, let me know. But let's look at how we can solve it both algebraically and in Desmos. So here, if you get something like this, we can go on to Desmos, and I'm going to make a regression. So remember, when you make the regressions, I'm going to make my x values all x1. So it's going to be 6x1 to the fourth power plus 17x1 squared plus 7. And that's all going to be equal to, or rewritten as 3x squared plus a, da, da, da. So I'm going to put a tilde in now because I'm making my regression. And let's go ahead and do that. So we have 3x1 squared plus a, and then we have 2x1 squared, and then plus b. Okay, so that's amazing. I see the a equals 7, b equals 1, but this is just telling me when x1 is equal to 1, it gives me these values for a and b, and I want it to say, like, for any value that x wanted to be, it will always be these integer values. So to make sure that that's true, you want to say x1 is equal to random, and you can choose anything. Let's just say like 201, and we can see that it stays the same. And this tells me, you see it removed x1 and basically saying like, hey, x1 can be any value, and it still gives me a and b as integers. So I know for sure a equals 7 and b equals 1. Now I want to do the same for the next situation. So I would type it in again. So 6x1 to the fourth power plus 17x1 squared plus 7. And then what I'm going to do is put the tilde again. And then we have our 3x 1 squared. And now instead of a, we have plus c. Oh, plus c. And then we have 2x1 squared plus d. And here you can see that I have c equals 7 and d equals 1 again. However, I want to now tell Desmos that um, that C and D are going to be positive non-integers. So what I'm going to do is tell it that. And what you do is you open the squiggly brackets, and I would say that mod. Mod is to use, we use mod to tell if a number has a remainder or not. So in this case, I would say C1. So when you divide C by 1, if we set it equal to 0, it would tell me that um, it doesn't have a remainder, but if it does have, if it's greater than 0, this will tell me that when C is divided by 1, it will give me a non-integer value. And I'm going to do that. Greater than 0. Oh my goodness. So it's always greater than 0, not greater than 1. So if it's equal to 0, you see it gives me different values, but here I want it to be greater than 0. Why is that? Because I'm telling Desmos um, basically that it's going to have a remainder, aka be a non-integer. And then what are we doing? We have to get the value of a plus c, type that in. A plus c is equal to 8.5. You can put that or 17/2 in your answer choice. And that's the answer. Wasn't that amazing and so cool to do on Desmos? Okay, but for those of you who would like to see it algebraically, let's do. So it's just really equation equivalences. So what we would do is x to the fourth plus 17x squared plus 7, and that would be equal to 6x to the fourth, and then we'd have plus 3bx squared plus 2ax squared, and then we have plus a times b. And then we can see equation equivalences. This will be equal to this. I know that 17 will be equal to 3b plus 2a. And I also know that 7 is equal to ab. And it says that a times b are positive integers. So the only positive integers that are possible to multiply and get 7 would be that either 7 is equal to a and b is equal to 1, or it's possible that 1 is equal to a and b equals 7. So then to see, I'd be like, all right, well, which one is going to be true when it's going to be 17 or equal to 17? So if we do 3 times 7 for b, that would be 21. And then 2 times a, that would be too large. So it must be 17 equals to 3 times 1, and this would be plus 2 times 7. And that's true. 17 equals 17. So then I know for sure that my winner is that 7 is equal to a, and this one is not true. Okay, and then we have our a and b values, and now we have to do the non-integer values. So same thing that we did, except we'll be expanding these brackets. So I would have that 6x to the fourth plus 17x squared plus 7 is equal to 6x squared. 6x squared plus 3dx squared plus 2cx squared plus cd. And then we use our equation equivalences again, except this time we would have 17 is equal to 3d plus 2c. So 17 equals 3d plus 2c. And then we would have that 7 is equal to c times d. In this case, I need to find positive non-integers. I do have two equations, so we can do substitution. Let's do it. So for example, like 7 over c is equal to d. And then we can put that in for our d value here. And then that would be 17 is equal to 3 times 7 over c, and then plus 2c. And then we have 17 is equal to 21c plus 2 over 2c over 1. Why? Because I want to get a common denominator. So then I would have 17 is equal to 21 over c, and then we would have plus 2c squared over c. Then I would go ahead and multiply each side by c. So then it becomes 17 c is equal to 21 plus 2c squared, and then put everything in terms of zero. So we'd have 2c squared plus 21, well, minus 17c plus 21 is equal to 0. And then we can solve for c, which then it doesn't look like this is very factorable, which is also unfortunate. So I would just refer to the graphing calculator again. And just to show, I would just put everything here on Desmos and look for the x-intercept. So this was my equation. It was C's instead of X, but I type in X because Desmos won't recognize the C's. It only recognizes X and Y variables when you're not typing in regressions. And we see there's the 2 points that there's 7 and 1.5. I want the non-integer solution, so that would be 1.5 or 3/2. So C equals 1.5, and then that's it, because now I have my C value, we have the A value, A plus C. Oh, I didn't want to erase it. A plus C is equal to 7 plus 1.5, which was exactly what we got when I typed it on Desmos. So you see both ways to solve. This is algebra. I don't know, maybe which one was faster for you? You can let me know in the comments. Okay, and continuing. Last question that I think you should be really aware of that I think will definitely show up on the exam on Saturday is the following. So this type of question, I believe that you will see a scale factor type question on your exam on Saturday if you're taking it this Saturday. And if you're not, it's a good concept to know because they've tested on multiple SAT exams. So just a thing about scale factors, because it seems to be a little bit complex for students, but when two shapes are similar, all their side lengths grow or shrink by the same multiplier. And we call this the scale factor. So lengths always change by, like lengths we say, change by a scale factor of k. The areas change by a scale factor of k squared, and volumes, their scale factor would be k cubed, k being the scale factor. So just to give a quick demonstration before we jump into this problem, for example, if I have a square, square A, it has sides 2, and then I'm going to make a similar square, but it has size 4, due to D to D. We'll call this similar square, it's B with sides 4. We see that the only thing that has changed for the length would be k. Everything's being multiplied by 2. What about area? 2 squared is equal to 4. 4 squared is equal to 16. So I can see what happened here. The area had a scale factor of k squared, right? Area is squared. And same, if we cubed it, 2 cubed would be equal to 8. And 4 cubed is equal to 64. So that's what I mean by the scale factor. It's easy to see it with a simple shape, but just remember that lengths always change by k, areas change by k squared, and volumes change by k cubed. Okay, so amazing. So let's tie it back to this problem. So this says right rectangular prism X is similar to right rectangular prism Y. The surface area of right rectangular prism X is 55 centimeters squared. The surface area of right rectangular prism Y is 880 centimeters squared. The volume of the right rectangular prism Y is 1600 cubic centimeters cubed. What is the sum of the volumes in centimeters cubed of the right rectangular prism X and right rectangular prism Y? Okay, so this one we can solve algebraically or we can solve on Desmos. Let's first look at Desmos and then I'll show it on well, okay, so here we go. Okay, so scale factors. So remember that they will have, we can find the ratio between the two prisms. So in this case, I'm going to take the square root of rectangular prism Y, so 880, and then we'll take the same, the square root of 55, and I'm dividing them and taking the square root because remember areas have a scale factor of k squared. And what this tells me is that the scale factor for the area, it's actually 4. So if I want to find what the volume is, I can actually just make a regression. And what we can do is put our little tilde symbol, and then since I'm looking for volume, I'm going to want to do the cubed root. So I would do cube root it. And we have rectangular prism Y, it's 1600. So I would put that here. And then what we want to solve for is like our unknown. I'll put U for unknown. And look, it tells me what the volume would be of right rectangular prism X is 25. Okay. So I know that's 25 and asked me what is the sum of the volumes of the right rectangular prism X, which was 25, what we just solved for, and right rectangular prism Y, which is 1600. So I would just do 1600 plus 25, which is 1625. So if you know the scale factor, it's really simple to solve and you can make a regression here on Desmos. So amazing, right? And just to see, to solve algebraically, I would basically do pretty much the same thing and just do like set a ratio for the surface area of rectangular prism Y over the surface area of rectangular prism X, and that's equal to 880 divided by 55. When I divide that, it gives me 16, and I want to take the square root because it is the area. And this tells me that 4 is the scale factor. And then if I know that 4 is the scale factor, and I know that volumes will scale by what I wrote earlier, which was k cubed, then I'm just going to do that, take it, 4 cubed is equal to 64. And then we'll do now the like volume of prism Y, which we're given 1600. And we'll put that over the volume of rectangular prism X, which we now um, have deduced as 64. And then that's equal to 25. And then the final step is to do 1600 plus 25. So it's easy to do without a calculator as well, whatever you prefer, but I just wanted to show it is solvable on Desmos. But you do have to know a little bit of the theory behind it, which is the scale factor theory. But anyways, feel comfortable with this for the exam on Saturday or whenever you take it, because it's a common topic and I believe it will rear its head on Saturday. Okay, guys. Well, I wanted to give you a little bit of a video before your September SAT. A lot of people have been requesting, so here you have it. Know these problems, be really confident with them, and let me know if they do appear on your exam on Saturday. And like, rate, and subscribe if you like this video. Thank you so much for watching, and I will catch you in the next video. Bye, guys.